Hello, I'm Michael Valeri, and welcome to the Valeri Analytics channel. This is our first SQL class of our 4-week SQL Immersive Series, SQL Immersive Series, entitled Select from Order by in Limit. It is a code along, and before we get started, please make an account on mode.com/SQL Server. I put in a link at the bottom of the page under the video description. What you'll want to do is just click sign up. You can use a Google account, or you can create just an account using any email. Google's the easiest I found. After you have that account created, you're going to want to sign in. So I'm going to click sign in here. And I'm going to want to click new report. So the great thing about Mode is that all the SQL is written in a web UI. There's no software to install. We're going to do everything in the cloud using the tables that I have uploaded as public work data sets in Mode Analytics. So let's click New Report. Here we are in the Mode Analytics Relation Database Management System, where we're going to write our raw SQL code. All of the tables can be found in the mvaleri 12 schema. The next thing that you're going to want to do is go to the Valeri Analytics YouTube SQL Immersive Curriculum Google Drive link, which is also in the description below. Once you have that folder open, we're going to want to click on Student SQL Immersive Guide, Class 1 to 4. For my purposes, I'm clicking on the Teacher SQL Immersive Guide, Class 1 to 4. And before we start writing any code, we're going to do a little review of the last video that we did to make sure we understand why are we writing SQL? Why is this important? I feel like if we know why, it's going to motivate us to want to continue the series and write better code. So I'm going to open up the teacher version myself. And when you open up your student version, you can make a copy into your own Google Drive. You can download it to your desktop if you want to save it as a Word document. So I'm opening up the teacher guide. Just loading here. If you want to make a copy onto your desktop, you can always just click File, Make a Copy, or Download, and you can download a Word version if you want, and edit it. I like to use this guide throughout the series because I feel that it's helpful in just writing notes. So use this as a note-taking tool. Before we get started, I want to start with this chart. And I want you to imagine that you work for a record company that sells CDs or albums. And you are the VP of marketing. And a business analyst has come to the meeting and has presented this chart to you. And the business analyst tells you, hey, VP of marketing, this is the total plays and the total albums by album release year from the year 2008 to 2012. The blue line is the total number of artists that released albums in that year. And the yellow bar is the total number of plays that those artists generated in that given album release year. So there's something going on here. We're measuring two aggregates over one dimension. The two aggregates are total artists and total plays, and the dimension is time, release year. This is what we call a dual axis bar and line chart, which are really powerful. But as a VP of marketing, I just want you to take in this chart for a moment and ask yourself, well, what questions can you expect to be generated? What questions do you have about this chart as you look at it? Okay, I have some of my own. First thing I want to know, if I'm the VP of marketing, is what happened in 2010? Why is there no data there? What's going on? Is it because we didn't release an album, or is it because the data is broken? Who knows? But that's a question. Another question I might have is, why is there a spike in plays in 2011? This VP of marketing is becoming pretty demanding. My next question as a VP of marketing might be, who are these artists? What's going on with this data right now is that it is highly aggregated. It is not detailed. It's just total plays and total artists, but we don't know who these artists are, and we also don't know which genres these are. We also don't know what albums these are. We also don't know what ratings these albums are. And this is where analytics starts. This is where SQL writing begins, is identifying a problem. We've got a list of problems here that the VP of marketing wants to solve. He's staring at this chart in the meeting. What's step 2? Let's talk about it. The analytics framework again. What's the first step? Identify the problems or the questions. We have a list of them, so we can start answering those as we learn to write SQL. What's step 2? We're going to extract the data using SQL. Step 3 is we're going to analyze that data using something like Power BI, Tableau, Mode Analytics, which is going to be the tool that we're using. Very exciting. I consider Mode Analytics to be the LaCroix of the analyze data phase. We've all moved on from Pepsi and Coke. 4 is we're going to answer the question. So now we're framing why we're writing SQL. This VP of marketing has these questions, and we're going to learn over time how we can solve these questions to the VP of marketing using the SQL keywords, which I've listed here in the document, and you can always write notes in here if you need to about the SQL keywords, SQL keywords. All right. So now that we know why we're writing SQL, let's hop back into the Valeria Analytics YouTube SQL Immersive curriculum, and let's open up class 01, select from, order by, and limit. That's what we're going to be focused on today. We're going to want to copy and paste all of this text from the SQL curriculum folder into Mode Analytics. And bada boom, bada bing, we have it here in Mode Analytics. Great. All of these questions are going to be answered using the mValeri 12 schema, which is the schema I've created in the Mode public warehouse. But let's just kind of take a tour of the Mode interface first. If you notice on the far hand right, under tutorial, Mode has a ton of public tables that you can use if you want to just query other data sets other than mine to practice on. You'll see a lot of Animal Crossing data. And if you click on, let's say Animal Crossing tools, for example, you'll notice that if you click on a table, what appears in the bottom right-hand corner, it is the schema of the table, the blueprint, the map, the list of the columns, and the data types. This is going to be vital as we're going on our SQL journey, our SQL journey, is our map, our guide. It's going to help us when we're writing our code. First thing I want to teach you in SQL before we start writing any code is just what a comment is, because you'll notice this entire document is like green. The text is green. So a comment is, this is a comment, and comments are created just using dashes. Or if you want to write a comment on more than one line, you can do a \**. So this is a multi-line comment on multiple lines, asterisk, \\. That creates a block of a comment, whereas this is useful for just a comment line. You'll notice this entire document is just a giant comment. And below each comment, we're going to write the answer to the SQL question that we're being asked. So let's start with question 1. Our focus area of today is just select from, order by, and limit. We're only going to be using those keywords. As the class progresses, I will incrementally add where, group by, etc. And things will become more complicated, but let's just start here for now. It says use the mValeri 12 albums table for these questions. So let's just copy this, paste it into Mode Public Warehouse, and see if that appears. Here it is. There's the table, mvaleri12.albums. You should also see that on your screen. I'm going to click on it, and I see, oh, there's a schema, there's the columns, and there's the data types. Excellent. There's our map. There's our guide. Let's leave this open on the right-hand side as we write these questions. The first question says, I want to see all records in the mvaleri12.albums table. What do we know about SQL? Well, every query that you write is going to start with select and from. SQL is case insensitive when writing keywords, so sometimes I'll write things in uppercase or lowercase. The choice is yours on how you want to write your SQL. And the table that we're going to be talking to is mvaleri12.albums. So if I type in mvaleri12.albums, you'll see that mode's really cool. It knows that there's a list of tables in the mvaleri12 schema, and it lists all of them here. We're actually going to touch all of these during our course of this SQL Immersive series. As I write albums, oh, look, it wants to autofill it for me. That's a really cool feature of mode, is that it will autofill the table for you as you're writing it, like in IntelliSense. So if I hit tab here, the table name just appears. So I want to see all records in the albums table. I'm going to learn select star. Select star means everything. I'm going to write a comment with just a dash dash next to star that says, show me every column. That's what star will do. So what we're going to do is we're going to select the entire table, star, every column, from the mvaleri12 albums table, and then it's going to pop out the entire table for us. Here is the albums table that we saw in the presentation from last class. So we have all the rows, all the columns. Excellent. Great thing about this table is it's only 16 rows, but can you imagine selecting star from an orders table at Amazon? What do you think would happen? Well, I've done it before. It would crash the database. And I went to lunch one day and did that, and my boss said, why would you do that? I said, I wanted to see what was in the table. He said, well, why didn't you just limit the records in the table return? Why'd you have to return all of them just to see a sample of the data? So let's talk about the next question, where I'll show you how to do that. So you can avoid crashing a database if you've got millions or billions of rows. That could be problematic. So it says, I want to see a sample of 10 albums and artists in the mvaleri12 albums table. What do we know about SQL? You always start with select and from. These are required. They're required for every SQL query. If you start there, you get the momentum going. This will start to become muscle memory. If you want to talk to this table, well, I'm just going to copy and paste after from here. I think that might work. And it says, I want to see a sample of 10 albums and artists in the albums table. You'll notice on the right-hand side, down in the corner, I've got the table schema. Excellent. That tells me the columns that are available. So it says that we want to see album as a column. So let's select album. And I like to stack my columns and keywords in SQL as my formatting. You could write everything on one line, but I think it ends up looking a little messy. So I'm going to write album. I'm going to hit enter. And then I'm going to put the next column that I want to see. And it is artist. So I'm going to write comma artist. You'll notice that I put a comma here. In between each column that you select, you're going to want to put a comma. For example, if you've got 2 columns, you're only going to have 1 comma in between the 2 columns. If you've got 10 columns of data, you're going to have 9 commas. What am I saying here? You're always going to have 1 less comma than you do columns in your SQL select statement. I keep saying SQL because I'm so used to people not knowing what it is, but you folks know it's SQL. So select album and artist, comma. It says I want to see a sample of 10 albums and artists in this table. I'm going to do limit 10. That's our other keyword. Limit comes after from. You'll notice in the Immersive guide that I've listed the written sequence of the keywords. 1, 2, 3, 4, 5, 6, 7. We'll talk about the execution sequence later. It's a little different. Just because they're written in a certain order doesn't actually mean that they execute in that order. But limit comes after from, so limit is always after from. And then if you're using a combination of the keywords, you'll want to follow this order. So we'll do limit 10. I'm going to highlight and hit run selected. Always going to highlight the code. And there we have it. We've got a list of the albums and the artists in this table. 10 records. Excellent. Let's move on to the next question. I want to see a list of artists in the mvaleri12.albums table. What do we know? Select and from yet again. Selected from yet again. mvaleri12.albums. That's the table we're talking to. So let's pop it in. Love just copying and pasting. I could just keep writing it. I want to see a list of artists. Let's just select artists from there. Run it. I take a look. There's a list of all the artists in this table, but I notice Red Hot Chili Peppers repeats itself more than once. It's in 3 times. So why is that going on? What do we know? The granularity of this table is that every row is a unique album. Therefore, if an artist released more than one album, their name's going to appear more than once. This could also be true for an orders table. You might have every row being an order and the country that that order was sold in. Well, the order ID is going to be unique, but the country that the order is sold in, that's not going to be unique because an order could occur in the same, multiple orders could occur in the same country. So sometimes you want to remove those duplicates because you don't want to see them in your result output, which is what we're going to learn next. How do you get rid of duplicates in your select statement so you're not just seeing repeat of items? Well, you're going to start with select and from. Nothing changes there. And you're talking to the mvaleri12.albums table. And if you want to see a unique list, we actually use this function called distinct. This is very powerful. We're going to be using this a lot in SQL. So let's write distinct left-right parentheses to indicate that we're creating a function. We want a function manipulates a column of data. So we're going to manipulate the artist column to remove the duplicates. So inside of that function, I'm going to write artist. So distinct, remove the duplicates from the artist column, highlight and run selected. And look at that. Now we have the duplicates removed. Red Hot Chili Peppers only once. You'll notice null is in here though. So there's an album or albums that don't have an artist name. Something to consider in the future. Let's look at this next question here. It says, I want to see a list of albums in the table sorted from A to Z. What do we know? Selected from yet again. It's coming back. We're still talking to the mvaleri12albums table. And if you want to see a list of albums in this table, what are you going to do? Select statement shows us the columns that we want to see. We look at the schema. We notice that there's a column called album, and so we write it in there. It says that we want them sorted from A to Z. What keyword could we use to do that? Well, we've used select. That's the columns we want to see from, the table we want to pull from. Order by. Order by sorts the rows from A to Z or Z to A. Let's use that keyword. It comes after from. All right. So we're going to write order by. Comes after from. And we want to sort on what column? The album column. We want to take a look at all the rows in the album column, and we want to rearrange them based on alphabetically A at the top and Z at the bottom. So we're going to order by the album column ASC, which means ascending order. Isn't that nice how Mode Analytics will just show you and just autofill that in? I love that. That's great. So ASC, what does that mean? That means A to Z or 0 to 100. And if you want to invert that and do Z to A, where you show the highest value or the highest value of the alphabet at the top, you use descending. Descending is interesting because as you descend down the stairs, the values at the top are going to be high, and as you go down lower, they get lower. That's a great way to remember it. And ascending is the inverse. So let's run selected. Here we go. We've selected album from the table, and we've ordered by album ascending, and we have the list of the albums, 808s and Heartbreaks. Numbers come before letters in SQL when you're sorting things, something to be aware of. So that's all in alphabetical order. That's nice. That's really useful. Let's look at the next question. I want to see a list of albums, their genre, sorted by highest to lowest price. What are we going to do? Select and from. What table are we talking to? mvaleri12.albums. Nice. What are we selecting? The album. I'm looking at the schema on the right. Enter. What else? Comma genre. Because I got more than one column, I need to put a comma in between each column, the genre. And it says sorted by highest to lowest price. When we're sorting something, what does that mean? Order by. We want to order by what? The highest price album at the top and the lowest price at the bottom. So we're going to order by what column? Org price. Descending order this time. Highest value at the top, lowest at the bottom. Let's highlight it and run it. I take a look at my result output. And, okay, I've got a list of albums, highest selling at the top, lowest selling at the bottom. I don't know the price of these items. I just know that this is the highest selling one and this is the lowest. So what do I need to do? Well, remember in the class before, just because I've ordered by something doesn't mean I've selected it. I need to bring the org price column to the forefront. So it's kind of operating in the background here. If I want to see it, I need to push it forward. How do I get to bring it forward? I'm going to throw it in the select statement. Good rule of thumb, when you're learning SQL, you're ordering by something, select it just so you can see if it's working properly. So I'm going to throw in org price and we're going to rerun the code. And there we go. Interesting. Greatest hits is not the highest selling album. You know what SQL does? It puts the highest priced album, it puts nulls at the top and then the highest price after that. So that's an interesting feature of SQL is that nulls will appear at the top. And then it will start doing your ranking. We'll learn how to get rid of nulls next class. But for the time being, that's how you rank data. I want a list of albums and the profit realized from selling each album. What do? Selected from. We always need select and from. They're required. They're in every SQL query that we make. From what table? mvaleri12.albums. We're back at it. So what do we want to see? We want to see a list of albums and the profit realized from selling each album. What column do we want to see? We want to see album. And we want to see the profit. Okay. So let's run. I put a comma in between the two because I have more than one column. It says column profit doesn't exist. So if I look in the schema, profit isn't there. The price I would get if I sold the album. It's not there. But the ingredients are there. This is where we're going to learn about aliasing, creating our own custom columns and calculated fields in SQL. So we have market value and original price. You know, if I was in Excel land and I wanted to know the profit of an album, I could make a column called profit, and all I would simply do is just say, hey, can you take the market value, the price it's worth today, minus the price I paid for it, org price, and then I would just make my own column. And I would get the profit. Let's do that in SQL. I'm going to go back. Profit. What do we know? Let's make a function here to the left of profit. Profit is the market value minus the org price, the price we paid for it. And then after that, I'm going to write as. What does as do? As is an alias. It renames a column to something more manageable. Otherwise, that column is going to pop out and just be called market value minus org price. So when we alias it as something, it's just more recognizable. We're saying we're making something here. So I love using as. So as is an alias, it renames a column, and we can just write it right after our functions or any column names that we want to create. Let's try to run this now. Operator does not exist. You know, this is going to happen when you're writing SQL, right? You're going to get an error in your code, and you're going to wonder what's going on. So this guy's really sad and says, looks like something's wrong. It says an error, operator doesn't exist, text minus double precision. Well, what in the Sam Ellington does that mean? Text minus double precision. No operator match is given. You might need to add explicit type casts. Let me ask you folks a question. text minus double precision, why doesn't it work? You may have been in 5th grade and seen something like this happen on a math test. Teacher may have said, how much is 5/8 plus 2/3? And your heart would shudder as you stared at such a question. Why? Because you're taking two fractions and you're adding them together, and there is no common denominator. There's no common denominator, right? Now let's think of this question. How much is market value, whose common denominator is its data type, string, minus the org price, whose common denominator is a number? What do we know here? There is no common denominator, much like the fraction. In order to subtract fractions, add them, you need a common denominator. In order to subtract and add columns, you need a common denominator, a common data type. So, how do we convert data types in SQL? The goal is we need to make market value a number so it can be, so org price can be subtracted from it. So what we're going to learn is the cast function. So I'm just making notes here. The cast function says, hey, take a column as some new data type. We learned about data types in the last class. Boolean, strings, numbers. Boolean, strings, numbers, dates. Trying to remember. So cast, you take some column as a new data type, and this is actually the syntax. So what do we need to do? Market value needs to become what kind of data type? Market value needs to become a number, because org price is also a number already. That's why looking at the scheme is so important. You get this a lot. Data types not wanting to communicate with each other. Sometimes they need to be the same for it to work. This is a number already. We need to make this a number. Really beating a dead horse here, but I just want to make sure folks know what's going on. We need to convert market value to a number. So market value, we're going to put the cast function around market value, and we're going to cast it as what kind of data type? As a number. Because if we get a number minus a number, we'll get a number. Can't do a string minus a number and get a number. They don't have the same data denominator. You'll notice that I put the cast function around market value. SQL, much like math, works from the inside out. The first thing that's going to happen here is that we will convert market value to money. That's step one. After we convert market value to money, because it's the innermost part of the parentheses, then we're going to subtract org price from it. So there's an order of operations here that we need, that needs to be true. We first need to convert it to a number before we can subtract a number from it. So we're going to put the cast function around market value. Just going to delete that. And then we're going to run it and see what happens. It says market value type number doesn't exist. Okay. Maybe it wants to be a float. Let's try float. Okay. This is really interesting in mode. It's saying that this column is a number, but in reality, org price is a float, meaning it has decimals. So let me try converting this to numeric. See if that would work too. Okay, it's taking some time. Okay, so org price really wasn't a number. It says it is, according to this, which is a little confusing, but that's okay. So it's really a number or a numeric data type. I think it's just a bug within this. Okay. Let's move on to the next question. It says, I want to order the list of albums by lowest profit album to the highest profit album. What do we know about SQL is that you need to do select and from. You always start with that, and we want to do mvaleri12 dot albums as our table. So it says I want to order the albums for lowest profit album to highest profit album. What do we want to see? We want to see the album name, and we want to see the album profit, and we want to sort it from lowest profit album to highest profit album. So we're going to do order by. And what are we ordering by? We're ordering by the column called profit that we're going to create. We've already created a profit column, though. It's up here. Unfortunately, it hasn't been added to the schema, so every time we want to query the profit column, we need to put the whole function in again. So I'm just going to copy and paste profit from this question up here, and I'm going to say, hey, it's just the same ingredients. I'm just going to make it down here in this query. So select album, order price is profit, and then we're going to order by profit. This is really cool. You'll notice down here in the order by, I just wrote profit. I can use aliases in the order by. You can use aliases in the order by because the order by runs after the select statement, right? This is what a lot of folks don't know about SQL, and I'm going to let you in on a little secret. The order in which SQL is written actually doesn't match the order in which it's executed. Let's go back to the immersive guide here. You'll notice select runs first, then it's from, then the where clause runs, or excuse me, the order it's written is select from, where, group by, order by, having limit. But the first thing that actually runs in SQL, even though it's not listed first, is from. First, we look at the table, then the where clause runs. Step 2, we filter on the rows that we only want to see. Then we select the columns, and then the other keywords run. So really the first thing that runs in SQL is from. Then it's where, then it's select, then it's the other keywords, order by, the other keywords in the factory. So let's go back here. Really what's happening is we're looking first at the mvaleri12 albums table, then we're selecting the columns or creating the ones that we want, and then we order by the profit column, which is created in the select statement. So this should work. If I want to order by the highest profit album to lowest, I'm going to write DESC after order by. So just a note here, you can use aliases in the order by, which is extremely powerful and very cool. So those are the first questions. Maybe in this workshop, you can do some of these on your own. So I suggest pausing the video right now and running through these questions below here and seeing if you can do these on your own. And then after you do them, jump back in, unpause, and I'll go through the answers. Okay, hopefully you were able to answer the questions below. I'm going to run through these answers very quickly. Question 1 says, select 50 rows from the mvaleri12.sales table. What do we know about SQL? We need a select statement from where mvaleri12.sales. It says select 50 rows from this table. What does it mean when we only want to see a sample of rows? We need to limit 50. We're going to select star. So show me every column, but only show me 50 rows. Let's run it and see what happens. There we go. Looks like this is just a list of sales for alcohol products. Okay. Imported products by counties and Looks like store number too, and date. What's fixed below code? Question 2. Oh, fiddlesticks. I didn't put it in this question here, and now I feel a bit embarrassed. I'll tell you what the question was, if this helps. Select total and store and county from mvaleri12.sales, right? And then limit 100. This was the code that I originally wrote. That's not this question. And interestingly enough, it seems to run regardless. So maybe this wasn't the best question. This shouldn't work, actually. There should be a comma here, because if you've got more than one column, you need a comma in between each column. So there's 3 columns here. There should be 2 commas. Let's go to question 3. It says, show me a list of store numbers, their name, and status. What do we know about every SQL query? We need select and from, and what table we're talking to. mvaleri12.stores. Excellent. So let's look that up here in our schema on the right. mvaleri12.stores. So here's our blueprint. This is our map. It wants to see the store number. So I see this column called store as a number data type. So that's probably the store number. And then it says it wants to see the store name. So let's do a comma name, because we're adding more than one column. And then let's do another comma and look at their store status. So let's write store status here. You'll notice mode actually does this autofill thing, which is kind of nice. It says order them by name from A to Z. So we're going to write an order by right below here. And it says order them by name. So let's order by name A to Z. That's going to be ASC. Let's highlight it and run it and see if it works. Nice. We get the stores, their name listed from A to Z, Z to A. Question 4, show me the list of items, their product category, and bottle price with 11% tax rate added on. Hint, use mvaleri12.products table. What do we know about every SQL query? Select and from. That's what we want. What table are we talking to? mvaleri12.products. What I like to do is if I'm querying a table, I like to bring it up as my map on the far right-hand side. So the products table. Show me a list of items. Okay, so it looks like this is a table of products. If I want to see a list of the items in there, it might be helpful to bring in, let's say, the item description so I can see the item number. What else? Their product category they want to see. So there's category name. What else do they want to see? And the bottle price with 11% tax rate added on. So let's do bottle price. And then let's do bottle price with tax. So bottle price is a column. Do we think bottle price with tax is going to be a column? I don't think so. There is a column called bottle price, though. So if we want bottle price with tax, we're going to have to create a function here, which is going to be the bottle price with its tax rate, which is multiplied by 1.11 as bottle price with tax. Let's call that calc1. There's another way you could do this too, which is you could take the bottle price plus the bottle price again times 0.1 or 0.11. There's 2 ways to calculate the bottle price with 11% tax rate, FYI. Whatever one you see fit. Should give you exactly the same answer. Yes, it does. All right, let's do question 5. Find the highest profit item. What do we know? Every SQL query needs select and from. Select and from. What table are we talking to? MValeri 12 products again. We've got it on the far hand right side. It says find the highest profit item. Let's pull in the item description. Let's pull in the item number. We've got more than one column, so we do a comma. And it says profit is shelf price minus the bottle price. Well, gosh, we can do that. To create profit, we're going to do left, right, parenthesis, and we're going to do shelf price minus the bottle price as profit. Shelf price, let's look at the schema though, make sure these are same data type, same data denominators. Bottle price is a number, and shelf price is a number as well. I know you can barely see it here because unfortunately there's this little chat icon, but I promise you shelf price here is a number. Let's run selected, see if it works. There we go. If we want to find the highest profit item though, ooh, I didn't do that. All I did was, if I want to find the highest profit item, I'm going to need to order by. I'm going to have to create the profit column, which I already did. And I'm going to have to order, if I want the highest profit item in the top, I'm going to do descending, right? And then I'm going to run selected. Highest profit item looks to be Cedar Ridge Barrel Proof Bourbon. Interesting, though. These are blank. They're blank. Why are they blank, though? These are all null. Remember when we do descending order, it will show the nulls at the top? But why are these all blank? If you ever want to know why something is blank or null, and you've created your own custom calculation, it's good to break that custom calculation into its independent columns. So I'm going to put shelf price and bottle price as their own column here and see what they would be. Because chances are one of these, shelf price or bottle price, is null. Okay, these are actually both null. Shelf price and bottle price. What do we know? A null minus a null is going to get you a null. So that's why we don't see anything here. So folks, those were the questions that we did in the code along. What I suggest you do is to go back to the Valeri Analytics YouTube SQL Immersive Curriculum folder and start on the homework, the 4-week SQL Immersive homework. Start on the homework tonight, or maybe tomorrow. Maybe give yourself a break for after class 1. I have the questions and the answers in here. The questions for homework 1 are going to be Pokemon data. So you're going to actually be talking to the Pokemon table, and it's going to be called mvaleri12.pokemon. Go through these questions, see if you can create them, and then the answers are in the bottom. After you do that, hey, maybe take a day break. Head on to class 2. We're going to learn how to filter data and aggregate data. Thanks for watching, and hope to see you soon. Bye.